Hello, I'm Mr. Matt. Welcome to topic 1.6 in the 2027 AP Statistics curriculum. Today we're going to be talking about the topic descriptions for one quantitative variable distributions. So we are going to be describing a distribution. Now, when we describe a distribution, there are several things that we want to pay attention to. And there is a nice little acronym that we can use to help us remember that. SOCS. SOCS. All right. So remember, when we are describing a distribution, we should always describe its SOCS. Now, what is SOCS? What does it stand for? It stands for shape, outliers, center, and spread. All right, so whenever we are describing a distribution of data, we want to describe its shape. We want to look to see if there are outliers, and we'll talk about what that means in a moment. We're going to look at the center, and we're going to look at the spread of the data. Okay, now in this topic here, we're going to primarily be focusing on shapes, but we are going to talk a little bit about outliers as well. And in the next section, we're going to learn some ways that we can measure the center and the spread. But let's first talk about shapes of distributions. So if you recall, in the last topic 1.5, we talked about different kinds of graphs of quantitative data. And one of those graphs was a histogram. And I mentioned then that histograms are probably the most popular way of representing quantitative data. So today we're going to be looking at some histograms that represent distributions of a quantitative variable. And once again, the quantitative variable that we're going to be talking about is heights of residents in a sample of 30 from Beijing. Okay? So let's talk about different shapes. The first shape that we're going to talk about is something called skewed right. Skewed right. Sometimes it is called positively skewed. It's positively skewed. And when we say that data is skewed right, what we mean is that the right tail is longer than the left tail. Now, what is a tail? Well, when we have like a peak, the top part of the data up here, well, then on one side and on the other side, we will have what's called the tails. So here is our peak, the top, like the highest bar in our histogram. And then these are the tails. We have the left tail and the right tail. And in this example, we can see that the right tail here, the right tail is much longer than the left tail. I'm going to click up here real quick and select a pen. All right, so we can see here that the right tail is much longer than the left tail. So when we have this type of shape, and sometimes we just draw the curve. So if we have a shape that looks like this, where the right side over here is much longer than the left side, and then this is the kind of the center of our data here, or at least it's the high point, the peak. So in this case, this is called right skewed or positively skewed data. Okay. Now, of course, if we have right skewed data, we also have left skewed. So skewed left or negatively skewed means that the left tail is longer than the right. So once again, here we have kind of a peak in our data. And then here is our left tail over here. And then our right tail is over here. Now notice again, our left tail is longer than our right. So that means this is left skewed. And sometimes we might just draw it with a curve like this. All right, so our peak is right here and our left tail is much longer. So this is left skewed or skewed left. We can say it either way, left skewed or skewed left. Okay. Next, Well, what if the left tail and the right tail are the same? Well, if that's the case, then we have what's called symmetric or approximately symmetric data. And that means both tails are about the same length. So let's look at an example of that. Here we have Beijing residents and their heights. Okay, so we have here, we have the peak of the data, and we can see that the left tail over here and then the right tail over here, they're about the same. They're not exactly the same, but they're close to the same. So if we have a situation where the center is here and the left and the right tail are about the same, okay, well then we call this approximately symmetric. It's symmetric data. All right, next. So these are all ways that our data might be shaped. And another way that we might describe the shape of our data is to talk about how many peaks it has. Now, for these three that we just looked at, these three sets of data, well, they are all what we call unimodal. Unimodal. Unimodal just means that it has one peak, one clear, distinct, definite peak. All right. So here, this data has one clear peak at the top, and then it comes down. So this is what we would call unimodal data. Same thing here. Now, even though there's like a little, you could say there's a little peak here, but that wouldn't be a clear, definite peak. That's just a little bump in the data. The clear peak of our data is way up here, and we have one peak, and then it comes down. So this is unimodal. Same thing here, unimodal data. So what other kind of data would we have? Well, we could have bimodal data, and that's data that has two clear, prominent peaks. So let's look at an example. Here is an example of bimodal data. All right, so we have a peak here, and then we have a peak over here. Okay, they could be connected. There could be data down here. All right, that if there was data down here, that's fine. This would still be considered bimodal because there's two clear peaks. All right, so when you have two clear peaks, all right, they don't have to be exactly the same height, but two clear peaks, this is called bimodal data because there's a peak here and a peak there. Okay. Next, what other kinds of data shapes could we have? Well, we could have approximately uniform data. Uniform means it's all the same. So this isn't exactly uniform, but there's not a clear peak and there's not a clear valley. It's a lot of data that's all very close to being the same. And so this is what we would call approximately uniform. So anything that looks kind of like this, where there's not a big clear shape to it, that's what we would call approximately uniform. So the frequency at each value is approximately the same with no clear peaks. Approximately uniform. Okay, so those are all different shapes of data. Now, in our SOCS acronym, we want to first talk about the shape, but then we want to talk about outliers. Well, what is an outlier? Well, outliers are data points that are unusually small or large relative to the rest of the data. So if we take a sample of residents from Beijing and we measure their heights and record them, we might get a lot of people between 160 and 175 or 180 or something centimeters. But what if we have one person that's super, super tall? All right. So here we have someone that's between 203 and 205 centimeters. So this would be what we call an outlier. It's some point, a data point, that is unusual compared to the rest of the data. This one is especially large compared to the rest of the data. So we would call this an outlier. Now, next, gaps. Well, what is a gap? Well, a gap is just a region in a distribution between values where there are no observed data points. So here is a gap. There's no data points between here and here, but there is data over here and there is a data point here. So this would be a gap. Same thing up here. Filled in this area here, but if we didn't fill that in, then we would have something like this, and there is a gap in the data right here. There's a big gap in the data. So pretty easy to understand. That's a gap. And then our final word that we're going to learn in this section is the word clusters. All right, clusters. And of course, a cluster is just a group, a concentration of data points that's usually separated by gaps. So this would not be clustered because this is just one outlying data point. But up here, these would be clusters. We have a cluster over here, and then we have a gap, and then we have another cluster over here. Sometimes that happens with data. And so we can say that this is clustered data. It's data that has clusters. All right. So those are all the new words and ideas that we need to learn in section or topic 1.6. So let's look at some practice problems very quickly. Here's the first one. It says a group of students played a game in which they earned points for answering questions correctly. The following dot plot shows the total number of points earned by each student. Which of the following is the best description of this distribution of points earned? So we want to describe this distribution. Is it A, unimodal and right skewed? B, bimodal without a gap? C, bimodal with a gap? D, skewed to the left with a gap? All right, so let's look here. Unimodal and right skewed. Well, I don't think this is unimodal because we have what looks like two clear peaks here. So this is going to be bimodal data. So it's not unimodal. So let's get rid of that. And then let's look at the next one here. Bimodal without a gap. Well, it looks like there is a gap here. Even though this is bimodal, it does look like it's a gap. So we're going to get rid of that. Bimodal with a gap, well, that looks like it could be correct. And then skewed to the left with a gap. Well, I wouldn't say that this data is skewed to the left. There's not a left tail that is longer than the right tail or anything like that. So our answer for this problem is going to be C. It's bimodal with a gap. All right, let's look at number 2. Number 2 says the distributions of 4 variables are shown in the following histogram. Which of the following shapes is not represented by one of the 4 distributions? All right, so which one of these shapes is not here? Is it A, uniform? Is it B, bimodal? Is it C, skewed to the left? Or is it D, symmetric and unimodal? What do you think? Well, let's look. Uniform. Are any of these data sets uniform? Doesn't look like it. I don't think any of these are all approximately the same. Okay, so I don't think uniform is represented up here, so it looks like it might be the correct answer. Well, is there bimodal? Yeah, this is bimodal right here. There's 2 clear peaks. There's a peak here and a peak here. Okay, so that means that this is represented, which means it's not the right answer. And then skewed left. Are any of these skewed left? Well, yeah, this one is. This is the left tail, and this is the right tail. The left tail is significantly longer than the right tail, so that means it is skewed to the left. So that is one of the shapes. And then symmetric and unimodal. Are any of these symmetric and unimodal? Well, it looks like this one is. All right, symmetric, this side are both the same on either side. And it has one clear peak right here. So this would be symmetric and unimodal data. So which means our answer is A, uniform. All right, so there is no distribution here that represents a uniform distribution. Okay, that's all. We're finished with 1.6. Hope to see you next time for topic 1.7.